Hi there, welcome back. Today I thought of doing a review in mathematics, so let's go ahead and start. The equation of a sphere with its center at 0, 1, minus 2, and the radius of 9 is... First, I would go to the FE handbook and let's type a sphere. There you go. The standard form of the equation is, and we have x minus h squared plus so on, z minus m. And these are the centers. So let's go ahead and write this equation down. So the equation of a sphere, x minus h squared plus y minus k squared plus z minus m squared equals to r squared. So now if I have the centers, if I was to plug in and for my equation here with these points, right, x is 0, so this is going to be x squared plus y minus 1 squared, right, and plus z. And look, be careful here, we have minus 2. Minus with minus, it's going to be plus. So we're going to have z plus 2 squared equals 2. And then the radius is 9, so we're going to have 9 squared. Or we can just rewrite this as 81. And this is the equation of a sphere with this center at 0, 1, minus 2, and the radius of 9. So from the get-go, if you are really aware about the equation of a sphere, you can see that the h value is 0, so c and d cancel out. So you only have to choose between a and b. And then here, just pay attention to the fact that we have y minus 1, and this is y plus 1. It only becomes plus when this component is negative. So in our case, the correct answer is A. Next question. The term 1 minus I squared over 1 plus I squared is most nearly. So here we have to deal with complex numbers. And the important thing here to remember is that the value for I is square root of minus 1. And this is what we're going to use here. And also, I'm not sure if you can find these equations in the FE handbook. I'll tell you exactly what I mean. Let me get a color, different color. So the formulas for A plus B all squared equals 2, and then A minus B all squared. And I have talked about this in my previous videos, these two formulas. Again, if you know that these are in the FE handbook, please leave a comment below. Otherwise, I'm going to just repeat and write them here. They are not very hard to memorize. We worked a lot in math classes with these formulas. And so I just memorized them. And the easiest way to do is follow here with me. So A plus B all squared is equal to A squared plus B squared plus, and then you have just double product of these two. 2 times A times B. And then if you go to the other formula, you have A squared plus B squared. So everything looks the same all the way up to here. And then going forward here, it's minus the double product of A and B. So see how this is actually not that hard to memorize. I think you can do this if these two formulas are not in the FE handbook. So next, let's go ahead and apply this and solve for what the problem is asking. We have 1 minus I all squared over 1 plus I squared. So just going ahead and come here. We have 1 squared following the formula plus I squared minus 2I. And at the bottom, we'll have 1 squared plus I squared plus 2I. So now, coming back here, if I equals to square root of -1, then I squared is going to be equal to -1. So if we substitute in this formula, I squared was -1, let's see what we get. We're going to have 1 squared is 1, I squared is -1 minus 2I, and then at the bottom we have 1 squared, which is 1, plus I squared again becomes -1, and then we have plus 2I. So now it becomes a little bit simpler. 1 minus 1 is 0. We have minus 2I at the top, and we have 2I at the bottom. So this becomes -1. Okay, so the correct answer is A. There you go. Let's move forward. A straight line intercepts y-axis at y equals 4 and also passes point P to x coordinate and y coordinate as 2 and 2. Determine the slope of the line. Okay. So let's see what do we know. We have that the line intercepts y-axis at 4. So we know the y-intercept here. Let me quickly, I'll draw this graph y, x. And so we know that the line passes at 4 at this point, right? This is 4. And then also passes point here, somewhere here. So my line goes something like this. And we know, okay, we know this point is 2 and 2. And then coming back here, we also know this point because it's 0, 4, right? There you go. So now we have to calculate the slope of the line. We can go to FE handbook, and I'm going to do that. And look here, we have the straight line equations very close here. And there's a lot of ways you can do that. You can use the standard form of the equation and find out for m. M is the slope. But I'm going to use something that comes very handy. I have all of the values. I'm going to use point slope form. So I have the 2 points and I have the slope. And I can just input all the data into this formula and find or calculate for m. So let's write this formula down. Y minus y1 equals to m multiplied by x minus x1. So from here, we can calculate for m, the slope, and m is going to be equal to y minus y1 divided by x minus x1. And here, we can just substitute because we have 2 points, and I'm going to do 4 minus 2, right? Go with these 2 guys, and then lower, we can do 0 minus 2. So I get 2 over minus 2, and the slope of this line becomes -1. Pretty easy to do, right? So the correct answer is B. Now let's move forward. Next problem. The polar form of a vector is 10, 130 degrees. The rectangular form is. So we have the polar form of a vector. There's 2 ways to represent a vector. We have the rectangular form where you know the coordinates, and then you have the polar form, which gives you the 10 is the length, and then 130 is the angle it makes. So let's say in this case, I will represent this in such way. You have the angle as 130, so I know it falls into this second quadrant, right? Has 90 and then plus 30. So I'm gonna represent this. This is the angle, 130. And then the length of this is 10. Let's look into the FE handbook. I'll go to polar form, and let's find the notations. So here is the little graph that I also used just now, where we have the length as r and then the angle theta. So in this case, what I'm going to do, coming back here, if I know this length is 10, I'm going back to x. This is going to be my y, right? This is going to be y, and this is going to be x. Or I can come back here and say this is x, and this is y. So I have this r and theta in the problem given as 10 and 130 degrees. And in the FE handbook, we found these notations where we have x. So the value for x is r cosine theta, y is this. And this is something you don't have to memorize. This comes from, if I was to calculate, let's say this angle is 130, that means that this guy is going to be 50. And from this right triangle, right, I can do sine of 50 is equal to opposite over this hypotenusa, which is 10. And then from here, y is going to be equal to 10 sine 50. Same with, if I apply cosine of 50, I'm going to find that this equals to x divided by 10. And from here, x equals to 10 cosine of 50. So the only thing I used here is the basic sine, cosine formulas. And you can find them in the FE handbook. If you have issues with that, you can leave a question in the comment below, but these are pretty basic. Anyway, so from here, we found the value for y, the value for x, which we can calculate, and this is exactly what we are going to do. Let me take my calculator. So I have 50 sine 10 multiplied. This value is, y is 7.66. And then x, let's calculate x, 50 cosine 10 multiplied. And for x, I get a value of 643. Okay, so another thing, what we have to remember is that in this second quadrant, x is negative, right? And y is positive. So we have to add the signs on these values. When I write my equation, the rectangular form, I have to say that minus 643 plus 766i. So this is, let's say, z equals to this. This is the equation. I did it this way because I wanted you to understand where these formulas are coming from, right? In the FE handbook. If you want to just go ahead and apply the formulas from the FE handbook, they're going to tell you, if you just apply this, so x equals to r cosine, let's do that. X equals to r cosine theta, and y equals to r sine theta if you were to just substitute, you're going to get 10 cosine 130. And then here you're going to get 10 sine 130. Let's see, I get 130 cosine 10 multiplied. So when you do that, you get automatically the value for it, which is 6 minus 6.43. This is minus 6.43. And for y, you are going to get, so we have 130 sine 10 multiplied. And for y, you get 766. So right away, let me fix this because I don't like how it looks like. There you go. So right away, you can come here and say that the equation will look like this, 6.43 plus 766i. But the reason I want you to understand where this comes from is that looking at the answers, sometimes you can solve this. If you understand where it comes from, you can pick your right answer without doing any of these calculations. So if you read this question and you look at this angle 130 degrees, you can right away know that this falls in the second quadrant, which means that x is negative and y is positive. So your equation has to look with a negative x and a positive y. And look at this. A and B, they cancel right away because the x is positive. So you can only check C and D. And checking C and D, we have a negative x, which is fine. But then we have a positive y and a negative y. So our y is positive. So right away, we could have just gone here without doing any calculations and choose option C as our correct answer. This is why I did the first part. It's important to understand how things are working so you can skip some calculation, especially on the exam when the time is limited. Moving forward, what is the cofactor matrix of the matrix A shown below? All right, so the cofactor matrix, how do we calculate that? In the FE handbook, I'm not sure if you're given anything on cofactor matrix. You are given the inverse, how to calculate the inverse, adjoint, and then determinants. So I'm not sure if you're given anything on the cofactor. So let me show you quickly how do you calculate the cofactor matrix. Let me take first, let's say, matrix A, A11, A12, A13, A21, A22, A23, and then this here you're gonna have A31, A32, A33. These are the elements of a 3x3 matrix. And so if you want to calculate the cofactor matrix for this, what we're going to do is, let's say we want to calculate, or let's say first the cofactor matrix of this is going to look like this. We're going to say A11C, A12C, A13C, A21C, so on, so on. If I want to calculate A11 of this cofactor matrix, I'll say A11C is equal to. So this is how it works. I'm coming here to the initial matrix and I want to calculate for A11C. What I do is I cross this. So I get this member and then I cross the line, the column and the line. And I'm left with these members. So the cofactor is going to be equal to the determinant of what's left from what I cut out now. A32 and A33. And then on top of just the determinant, I have to check. So the 1, 1, this element, 1 plus 1, is an even number. So that means that I'm going to get a plus value in front of this determinant. And if I was to calculate this A12, moving forward, if I am calculating A12, the cofactor of this matrix, this element, this is gonna give me, let's cut this out, let's take this out. So this is gonna be, I have to take this circle out, cut out the line in the column, and I'm left with the determinant for A21, A23, A31, A33, and then since 1 plus 2 is an odd number, I'm going to add a negative in front of this determinant. Okay, and then the value moving forward, I'm going to have A22, A33. Calculating the determinant is not hard for a 2 by 2 matrix. A32. And here you're going to have minus in front. A21, A33 minus A23, A31. Okay, and then the result, it's going to be the coefficients of your cofactor matrix. And you do this for every single element of your matrix. Now, coming back to our problem, we obviously don't want to calculate every single element because that's time consuming and you don't want to do that on the exam. What I'm going to do, pay attention to what I'm going to say now. I'm going to identify, let's say, an element in our matrices here in our options. There's different in every single option. So if I get my answer, I know exactly which option to choose. What I mean by that, let's say, if I go here and I say, well, I'm going to calculate A11, right? If I do that, A11 is 0 in every single option. So if I get 0, I still don't know which option is the correct answer. So what I have to do instead, if I come here, let's say 36, look at A12. I have 36. I have 28. I have minus 28. And I have minus 36. So they're all different. So if I want to come here and I'm going to do it, A12, excuse me, let me delete that. A12, then if I get, let's say 28, then I know right away that B is my correct answer because the element in position A12 matches with what I have calculated. So the correct answer would be B. Okay, let's go ahead and do that. So I'll take A12 for the cofactor matrix and I'll calculate it. So it's going to be equal to, remember about this sign, I have 1 plus 2, it's an odd number, so I'll get a negative sign right away from the get-go. And then I'm coming here at my initial matrix, and I take A12, and I'm going to cross out the row and the column. Okay, and I will take the determinant of the matrix left, 7, 4, 5, 8. There you go. And now I get minus 7 times 8, 56, minus 4 times 5, 20. Okay, and if I open the parentheses, I get minus 56 plus 20. And this gives me a value of minus 36. I found that in the cofactor matrix, the position of A12 is minus 36, which matches with option D. So D is the correct number. You know right away what is the correct option by doing just one single calculation. I hope that's clear. If you have any questions, please leave them in the comment section below. So I have a few more problems left, but I'm kind of run out of time for today, so I'm gonna have to leave them for the next week. If you have any questions, please leave them in the comment section below. If you found this video helpful, please give it a like and subscribe, because this helps put this video in front of more people just like you. Have fun practicing, and I will see you next week.